All right, so let me show you some of the JUnit framework and in actions, and how are we going to write some of the unit tests. It's really simple, and I hope everyone can try to follow the same practice. And no matter whether you're using Java or not, it doesn't matter. You can always get the same kind of framework ready for your project and then start write some tests. Okay, so I'm going to focus on Java because this is JUnit is the most famous unit testing framework, and a lot of the new JUnit unit testing framework are following the same kind of a style. Okay, so let's actually start with some code first. Okay, so I'm going to write a new class, and I will create a new package with a new name here called demo. I'm going to do something really simple, like something called a calculator. All right, for the calculator, I'm going to have a class, and I will call this calculator. And the calculator can do different things, and I'm going to do a really simple method, which is called add. Okay, we got two numbers. I'm going to add them and then get you the result, and then obviously the implementation will be a plus b. All right, so very straightforward. Now with this, let's think about how are we going to test it. Now I bet before we're talking about JUnit, most of the time we're testing it just by running it. Right? That's a very straightforward way to test it, because you want to make sure your code runs and then give you the result you are expecting. So what I can do is I can go and create a main method, and then I can start to try this by creating my object. With the object, I can call this method. I can say 10 plus 20, and I can see what is the result. Once I got a result, and I need to print it so that I can see this is the correct result. So now I have my code ready. So I'm going to run this. All right, so I see a number 30, and looks like this is the correct result. And to be safe, I will change it. I will do a 15 and save it and run it again. Oh, it's 35, so that is correct. Right, so depending on the complexity, you might want to run this code as many times as you want in order to increase your confidence. But this is a very typical way of running a test. You call this method, you get the result, and then you print it. Once you print it, as a developer, you will decide if this is correct or wrong, because you know what is the expected correct answer. So this one all works, but that's not really the testing we're looking for. A few issues, because number one, you need to manually supply this number, and then you have to read this number and understand it. And that's a manual process. And number two, that you must know the correct answer. And if you're not sure about the correct answer, then there's no way you can verify it. And then you might know the correct answer, but you cannot guarantee later on when another developer jump into the same code, they can understand the correct answer. So that's why this kind of approach doesn't really work, or it doesn't scale. What we should do now is we should try to give some automated messages so that we do not rely on humans to decide it. So we can start from a very simple approach. For example, I'm going to do something like this. So I'm going to say if this result equals to 35, that is good. This is the correct answer. So I'm going to print to say correct. Otherwise, and I'm going to say it's incorrect. And I don't have to print this one anymore. So now I run my code as can be expected, and this is correct. And if I try another one, this time it should be 40, so I'll do this at 40. And that is also correct. Right? So this one is a little bit of improvement, because this time I don't need to understand the correct answer. I don't have to look at this one and compare. I just need to see the message if it's correct or incorrect. So let's say that my code got some bugs. Instead of a plus b, I did the a minus b. Right? So now I run my code again, and it will print incorrect. All right. So this is a very simple, but it's a big improvement, because now you don't have to spend too much effort to understand the result. But still, it's not perfect, especially when error happens, right? So I need to know the error in a much more formal way. And you print incorrect, it still kind of requires a developer to understand it, or at least understand the language, right? So what if I want a machine to run this and verify the result? And I need a better approach rather than just printing a message. So one thing I could do in Java is I can throw a exception, right? So I can throw a runtime exception, incorrect. So this one is a lot better because when you run this program at this time, and you will see a formal exception in Java. And then if you want to capture or understand this exception from other code, and Java can do that very easily, right? And then I can just go ahead to fix this. Now I run this code again, and it works. So this is a much better way than the previous approach to verify the result. And then if you understand it, what I can do is I can just do it one more time with a different test case. Okay, this time I'm going to do a result 2. And result 2, I'm going to try, for example, negative 25. And then the result should be negative 10. All right. So now I'm going to run this code again. All right, so both are correct. So as I'm writing the code, you start to realize the kind of testing we're looking for. So we're looking for something that's automated. You run the code, it will run the test for you. And then we're looking for some automated verification and tell you the result, whether it's correct or it's incorrect. And also we really care about how many things are not correct. And I want to know that in a very formal way so that the machines can also understand it. That's why we use some exceptions. So these are the basic idea of unit testing, because if you do this and a new developer comes in, they really don't have to understand much of the logic. They can just run the thing, see if everything is correct, or something is wrong, then they can dig into the logic and see what else to improve. All right. So this is the kind of unit testing we're looking for. So when people realize this is a kind of a preferred approach to test, and then we want to create some library and framework to simplify the process, because we do not want people to always write these things here and these ones here to repeat the if statement and then store exception. It's kind of a tedious. All right. So that's when the JUnit comes on board. All right. So to use JUnit, you need to first of all include the package, the library dependency. JUnit is not a built-in package for Java, even though it's a very popular library. So you can find out the JUnit library online. Let's go Google JUnit. All right, and then right now it's JUnit 5. It's a very new version, and I might just stay with JUnit 4 just because it has some of the very standard thing that's still being used in most of the code bases. And there are a lot of versions, and then 4.9, 4.12, 4.13. So I'm gonna probably try the 4.13. And then if you try to install this dependency, you can use Maven. So let's click on download and install. As you can see here, you got a Maven dependency. You can just copy it, and then we can put it into our POM file since we're using Maven. Now, if you're using a different framework, and please think about how you find that dependency added there. Okay, so I'm going to add this one here. So there is a JUnit. I'm going to replace this one with this new version, which is 4.13. Okay, once I save it, and then you can find that the JUnit library comes here. All right. So once you got a JUnit library, you can start to write test. Now, a couple of things to keep in mind. Now, first of all, in Maven, we want you to split your test code with your production code. So this is the production code. The test code should not be put together, because in this case, as you can see, the code is very messy. And this code really has nothing to do with the functionality, just for you to test. So they should not belong to here, right? So that's why we should not actually put the code here. Okay, so I'm going to leave here before I totally delete them. So you should put this one in a different package here called the test folder. And then you also need to keep the same kind of a package. Like in this case, it's called the demo.calculator. So right here, you also need to do the same thing. Calculator. And then when you're writing a test in a different place, you also want to follow some kind of naming convention. So like in this case, the class is called calculator. Now it will be good if you write the test case into something called a calculator test. Okay, so this is the code convention, and all the Java developers are following it. And I think Maven might also looking for this kind of code convention to seek for your test files. And then inside this class, you can write your test code. And then you can write a test code for every single method. For example, here you have a method called add. Now, in this class, I can do something called public void test add. Okay, again, there is a convention. So you always do something called test and then the name of the method. All right. So how do we test? Now we're going to test it by using the same logic. I'm going to do a calculator. I have to create this instance. This is the same part as before. And I need to run and get some results. For example, 10, 20. And next step is I need to compare the result. And in this case, that's where the JUnit can simplify it. You don't have to write all the if statement by yourself. You can say something called assert, and then you can say assert equals. And then you can provide something called expected value. In this case, it's 35. And the actual value is the result you get from the code. Now, you might see this kind of deprecated sign here. It's just because the JUnit did some refactoring, so some of the name got changed. Okay, so I'm going to change it like this, so it will be gone. So this assert equal, this one comes from JUnit library. It's not a Java library. And all it's trying to do is trying to compare if the calculator result is equal to this one. All right, so that's how you write a JUnit test. So as you can see, it's much more simple, concise, and also it's much more straightforward and easier to understand. And then finally, you need to mark a annotation at the top of this method to say and tell JUnit that this is my test case. Again, this annotation comes from JUnit. It's not from Java. And now you finish your test case. Once this is done, okay, I can run my test case. To run my test case, I can go here, right click in Eclipse, and then you can find something called run as JUnit test. Okay, and you click on JUnit test. All right, as you can see, and something is wrong here. All right, so we go and find, and then they said that, oh, they if you look at the message here, it said that they expected the 35, but it was 30. And in this case, obviously, we made a mistake. I made a mistake that I put the wrong result here. So the expected value should be 30, not 35. And then let me rerun this again. And this time it's all passed. So that means I'm looking for 30, and then you gave me 30, so that's all good. Okay, and you can see from this example, the purpose of JUnit is try to replace this kind of a logic you wrote manually. All right, and it can tell you if things are right or wrong with this kind of formal tools and the status bar, and they will give you statistics to see how many tests we ran and how many error, how many failed. All right, so let's say that now the code has a bug. So now it's not A plus B, we do A minus B. And then when I run this again, you start to see this thing got failed because we expect to see 30, but then you give me a result -10. What happens? All right, something wrong with your code, and then you go to find the problem, and it's actually because of this, and then you go ahead and fix it, and your code passed. So that's how JUnit works. Now you could add a lot of test cases. Every test case is better to kind of make it as one method. So split them, and then this one I'm gonna do 100, and then this one you do a different result, and then try to run this one here. As you can see, there are 2 test cases, and then both are passed. And obviously, the more test cases you have, the better, right? So I can do one more, and then I will do 3, and I can do some kind of a negative numbers. All right, and then run this again, and it's all passed. All right, so that's how the JUnit testing works. All right, so it's really simple and straightforward. So it has this annotation called test that helps you. Now JUnit has a lot of other things that you can use. One thing is the assert. You have all different kind of assert approach. You can compare two arrays if they're equal to each other. You can compare if something is not null or if it's null. You can compare if they are the same. If you're talking about like a string, there are different kind of approach that you can compare in the third thing. But I can tell you, the third equals is the most important one, and because you can do anything with the third equals. The other methods are just kind of utility helper method for you to simplify some of the testing process. All right, so and then another one is about annotation. So the test annotation is the most important one. Now you also have something called before and after. That's also common. So I'll just show you a quick example. So the before annotation means that you want to run something before every single test case. So if I try to do this one before testing, and then if I run this again, as you can see, this one will be executed 3 times because you got 3 test cases. And right before you're running every single test case, they will run the before method. Now, normally you use this one to set up some of the basic test case, right? For example, I can do things like this because here I initialize this one 3 times for the calculator. And I can just do it once. I can put a private, okay? But right before it, I'm gonna recreate a new instance. So in that case, I don't need to provide this one anymore. I can just delete them. All right. So now when you run it, it works the same. And then there's another one called after. You know, for the after, normally I think it will be used for some cleanup logic, right? So after, and here I'll just show you a message that finishing and cleaning up the test. Now we'll run this code. It will do the before and then after. And then in between, we'll run the test case. So test, before, after, these are some of the common annotation used for JUnit. And there are some other ones, but then it's not really too often. All right, so now your job right now is try to stick with one of the unit testing framework for your language. It doesn't matter whether it's Java, C#, JavaScript, Python. You can all find the test case library to use. In exactly the same way, they will all provide some kind of assertion statement, and then they will all provide some kind of framework for you to kind of try to capture the errors. And then also make sure that you're using the test case inside a build tool. Like in this case, we're using Maven, right? When you have a Maven, once you finish the test here, when you go to the terminal to build it, and you will be able to see that test will be executed in process of a build, right? So let me show you this. So I'm gonna go to, oh wait, I need to find out the folder. I think it's in different folder. It's called a CS4800 demo. I think this is the one. So now remember, I do something called a Maven package. I can, generate the whole like jar file, right? Now here, okay, so there's some compile errors. So the source option 5, it looks like we got some errors on the Java version. And let's see if how we can change that one. Okay, let me actually get a new one from a different place here. I think this one here controls the Java version. I'm going to try to use Java 7. I think this is somehow use a very old version. All right, so I will put it here. Okay, so I'm trying to do the Maven package again. All right, so this time it's success. As you can see, part of the build process has a test process and it runs 3 test cases. That's the one we just wrote, as you can see. And the really nice thing about this one is you ever fail the test, it will be captured. For example, if my code has bugs, all right, so I go here, this code here has some bug, and I go back, I run this again, it will not succeed because this one here, the test case got failed. And as you can see, this is the same kind of errors we can see from the unit test console here. Until you fix your bug, you will not be able to generate the jar file. Now I fix it, and then everything come back to normal. So as you can see right now, this is the reason why all the developers are required to write unit tests, because when everyone is is contributing our code together. Now we want to make sure that the whole process still works. And when we have many people, it's very hard to manage that. So that's why if everyone checking their unit tests, and then every time we're trying to build our software, we'll make sure to go through all the tests and then make sure that the things are running correctly and as expected, right? So this is a very important practice for agile development, because if you don't do this, and the quality of the software will go out of control very quickly, especially after all these frequent cycles and frequent iterations, and then customers will get a lot of complaint. All right, so your next goal will be clean up the code and then try to test, write some unit tests for yourself. All right, so eventually your program code will be very clean, and then your test code will be separated. Okay, so that's how the JUnit works.